We're going to look at two more examples which really do fit under the mixture idea. In this one, we need to use the fact that similar to rate times time equals distance, if instead our rate is about time, if our rate is about working, then rate of work times time worked for will equal the amount of work done. And so let's write that down. Rate times time equals work. Or if you like, R times T equals W. Now, rather than using the 12 minutes for Clark biking to deliver an entire route and the 60 minutes for Lois, we're going to use furthermore that if we divide both sides by T, that's going to give us our rates. Why? Because the initial information here is about Clark and Lois getting one entire job done. And so we have for Clark that he gets one job done per 12 minutes. Let me erase that because that's for Lois. And so Clark would be getting one complete job, the same job done, one per 12 minutes. That's the rates. We're asked how long it takes them to work together to get the same job done. So if we call X time to complete one job together, fill that in for both, and multiply straight across each row. 1/60th times X, or X over 60. And for Clark, the amount of work he would get done in X minutes would be 12. Now, because they're working together, that 12 and that 60 is probably actually really an average, and that from moment to moment there's some variation in the rates. But in algebra, we can't deal with that variation in rates. That's something that you can begin to deal with in calculus. So we're going to think of this idealistically, that that's a constant 12 minutes that it takes him to get that one full job done. And similarly for Lois. Well, let's furthermore idealize this situation that they have split up the routes, the routes with no overlaps. And they're not chatting with each other as they're working. They're actually working to speed each other up. That means that what we get for X should be something less than both their speeds. Our answer should be less than the lowest of those two speeds, 12. It should be less than that. We've got two options here. One would be to add their rates to get a combined rates. And if it takes them X minutes to get this done, to get one whole job done, then their rate would be 1 over X. And I could get a common denominator of 60 because the 12 already goes into 60. Multiply top and bottom of that second by 5. That's going to add up to, that should be 1 over X on the right side. So that's going to equal on the left side 6 over 60. And that reduces to 1/10. So 1 over X equals 1/10. The simplest way to deal with this would be to flip both fractions over and they will still be equal. But if you would rather cross multiply, 1 times 10 is 10, X times 1 is X, so X equals 10 minutes. So again, what I did here was I combined the rates.